Hi everyone. In this video, we're going to do a quick introduction of something we've talked about in the past about having a square root of a negative number. So we've already talked many times about how if we have a square root function, we have to make the domain so that we don't get negatives under the radicals because that's not a real number. So we're not going against anything that we've previously said, but we're going to come back to this idea of having a negative under the square root to see what more can we do with it. We're going to see in chapter 3 with a lot of solving quadratics, it might come up that we have a negative underneath a square root. So we're going to figure out, well, what does that mean about the graph? What does that mean about the solutions? Things like that. So we come back to this idea of what can we do with something like square root of -9. This is still not a real number. Okay, so I'm going to make a couple little notes. This is not a real number, but we can do more with it if we go through a definition of what we call this imaginary number. So in order to be able to deal with situations like this, we have this imaginary number that defined as I, okay? If we use an I in a value in a solution, it tells us something about the graph. It tells us about the type of solutions that we're getting. So it's not that it's a made up thing. It's a definition of this type of numbers, and it helps us simplify things that we couldn't do before. And I'm also going to talk about the difference between a complex and an imaginary number in 1 second. So let's just go through what this definition of I is first, and then we'll get to do some actual applications. All right, so the definition of this I, so it's like a little cursive I is defined to be the square root of -1. I'll show you how to use it in a minute, but the idea is that the I replaces the -1 under the radical, and it lets us then just focus on the number. So this is an imaginary number, okay? That's the key thing we want to remember, that this is an imaginary number. Not made up, but it's a different part of our number system. We're used to looking at the number system as their real numbers, but there's really an entire other side of our number system, which are these complex numbers, which include the imaginaries. So before I do any more with just I, it's very interesting, at least to me, and to any mathematician, about the second power of I. So I usually like to do this in class, but we're just trying to get a little head start in here. We wanted to try to look at the definition of I squared. Now, if we know the definition of I, which is right up above, just kind of think about what would happen if you squared both sides of that to get the definition of the second power of I. And so if I squared both sides of that above, then I would get I squared equals -1. So hopefully that's really interesting to you, because that is a real number. So the idea is the first power of I is imaginary, and the second power of I is a real number. And it keeps alternating like this. Together in class, we'll look at powers of I. We'll look at not just the first two powers, but we'll look at even more powers of I after. So both of those are going to come in handy, I and I squared. All right, the last thing I want to do before we get to some examples here on the next slide is let's look at the difference between complex numbers and what we call, if we say like purely imaginary numbers. All right, so when I talk about a complex number, I'm talking about something like this, a part that has a real and imaginary part. A real and an imaginary part. Okay, something attached to an I, and then something that's just purely real. When we talk about imaginary numbers, we're really talking about things that are purely imaginary, like 3i, or -7i, or I radical 5. All things like that are purely imaginary. Okay, so how are we going to use this? So I'm going to go to my next slide here, and let's say, how are we going to use this power of I, this definition of I, to come back to something like this. Now, you're going to be really quick at this eventually, but I just want to show you why this simplifies. So probably people that have taken Algebra 2 in high school remember it fairly well, might be able to give me the answer right off the bat and say, all right, well, that comes out to be 3i. But this is the reason. The reason why it comes out to be that way is that to simplify a radical here, we're able to write it as the product. We're really factoring but we're just factoring a negative 9 into negative 1 times 9. Right? So we're taking that, what's underneath the radical there, and we're writing it as the product of two things. I picked these numbers because, all right, square root of negative 1 is defined to be I, and we know that the square root of 9 is 3. And then we usually just write it as 3i, the same way we would write 3x. We put the coefficient in front. So likewise, if I had something like this, now maybe at the beginning you might write it like this. But, you know, within a few problems, you might be able to go, yep, I know if the square root of 100 is 10, the square root of a negative 100 is 10i. Let's do it for some other ones that are not perfect squares. This will give us a nice review of factoring and simplifying radicals. Let's try it for something like this. So we're kind of reviewing two things here in this one. How to use the I for that negative under the radical, but also what do I do with a 12? And it hasn't come up in this class yet, so it's a perfect opportunity to be able to simplify a radical, put it in lowest radical form. So 12 is not a perfect square. So what I have to do is I have to rewrite 12 as two numbers. I'm actually going to put the negative 1 right there. And I'm going to focus on just the 12 now. So what numbers can multiply to a 12? Well, 1 and 12, 2 and 6, and 3 and 4. I want to pick the pair of those where one of them is a perfect square, because that will help me simplify more. So I'm going to go with the 3 and 4. And so let's see, I usually put the perfect square and then what's not a perfect square, but it doesn't really matter the order that you do. So 4 times 3 is the same as 12. We have the negative in there to take care of the negative. And by doing that, by breaking that 12 up into factors, it helps me to simplify this part. At least that part can become a nice whole 2, and I'm going to bring it out front. This part is going to become an I. And then the radical 3 is really in lowest radical form. Having a 3 underneath a radical under a square root, it has no perfect squares that divide into it. So this is really the lowest form of that. So let's try a couple more of those before we do a few other things here. All right, so let's try, I'm going to have you try these ones right here. I would like you to try to simplify negative, let's do a negative 50, and let's try a negative 48. So I would like you to try to put those in lowest radical form. So I'm going to have you just put those in your notes, and then when I walk around and check that you did these videos, I will check those as well. The last thing I would like to do is to come back, go to my last slide here, and let's look at examples like this and to see what would we do with these. Because a lot of this is intuitively you're going to have already guessed what we should do. So we're going to look at that one. And then we'll look at one more. So these are already written in terms of I. So we don't have to simplify the radical on either one of these. We have to be able to just see how could I simplify, or actually my directions on these two would not really be to simplify, but they would be to multiply. If I wanted you to multiply these out, they're in factored form. How would I do it? So probably most of you are already guessing, you know, you will do the same thing as if those i's were x's, and you're absolutely right. Once everything's in terms of i's, we really treat I just like a variable, just like an x. So we would multiply out and FOIL here the same way we would if those were x's. So let's do that. So we'd have 15 in the front. We would have 6i in the back, minus 10i on the inner, and minus 4i squared in the last. So let's see what we can do here. Now, just like when these were x's, normally the two middle terms combine. So we'd have a 15 minus a 4i squared. Oh, sorry. Let me get rid of that. I was looking ahead. So that would be a minus 4i, and then we had a minus 4i squared in the back there. So if we remember back to our first slide here, right, we said the definition of I squared is -1. And since that's a real number, if I see an I squared in my answer, -1 is always going to be a better version of that. So if I plug in -1 here, it would be multiplication, -4 times that. Really, I have this. That's really going to become a +4 in the back. So what happens is when I'm multiplying these two complex numbers, I will get a real part. In this case, it would be 19. And I'll get an imaginary part, which is the -4, because it's attached to the I. So whenever I'm multiplying these two and that last term gets me some kind of I squared, it always joins to be part of the real part. So I want you to do this last one right here in your notes. And again, this will be part of what I check when I check these videos.